Hey YouTube, this is my first video in a module that I'm doing on two-way table analysis. And so we've been exploring probabilities, both theoretical and experimental. What I want to look at is how we could use what we call a two-way table in order to, organize data from a situation where, we have several events maybe happening and maybe they overlap a little bit here. So taking a look at this two-way table and how this represents a Venn diagram, let's do a little bit of reading here really quickly. We say that a two-way table displays the same information as a Venn diagram, but that in a two-way table, one category is represented by the rows and the other category is represented by columns. So we say that the Venn diagram shows the results of a survey in which 80 students were asked whether they play a musical instrument and whether they speak a foreign language. What we'd like to do is use the Venn diagram to complete a two-way table. And then what we're going to do is use that two-way table to answer these questions and kind of talk about the connection between the Venn diagram and the two-way table, but also how this two-way table is really kind of advantageous when it comes to finding different probabilities. So let's go ahead and take a look at this situation. We had a survey of 80 students. It looks like they either play an instrument or they don't, or they speak a foreign language or they don't. So in terms of our table here, our two categories are play an instrument or speak a foreign language. You can see that it's set up, and I'll go ahead and I'll kind of outline, from here to here. This would be our main table portion right there, where we either speak a foreign language or do not speak a foreign language, are our two row representations, and we either play an instrument or we do not play an instrument, are our two column representations. And everything at the bottom here on the outside are going to represent totals. So using this Venn diagram, let's fill out what we can. It seems to me that there are 16 students that do both play an instrument and speak a foreign language. So with respect to where that lies on the table, what we would do is we would look for play an instrument and speak a foreign language, and it looks like those two things intersect in this cell of the table. So what we're going to get here is 16 students that both play an instrument and speak a foreign language. Now, in terms of what else we know, I suppose how many students play an instrument but do not speak a foreign language, we could say that it's really just this outer portion of our Venn diagram here. So it would be the 25 out here, not the 16 in the middle, we'd say 25. So total playing an instrument, I suppose we could add the 25 and the 16 together. Here we get 41 total students. So now looking at foreign language here. Speaking a foreign language, but not playing an instrument. So we would say speaks a foreign language would be this top row, but does not play an instrument. It looks like we have 30 students there. And in terms of how many total students we have speaking a foreign language, I suppose 30 plus 16 here total would be 46. So we would say there are 46 total people who speak a foreign language, 46. And could we have gotten that elsewise? Suppose we could have added these up right here. So in terms of what else we would want to know, how about do not play an instrument and do not speak a foreign language? It looks like we have 9 of those out here. So we say 9. So total that do not play an instrument would be the sum of this column here, 39. And then if we were to say the total that do not speak a foreign language, we could say 25 plus 9 here is 34. 34 people do not speak a foreign language. So in terms of what we get down here in the bottom right cell, it's really important to notice that this will represent the total of this column, or the total of this last row, which should be the overall amount of data. And when you look at this 41 plus 39, suppose I get 80, that'd be the same thing as 46 plus 34 is 80. So filling out this table is a relatively simple thing to do. In terms of what we want to use it for, though, let's go ahead and take a look at some of these questions we're trying to answer. So for instance, letter A here asks, how many students play an instrument? So we could look up here, we could say, well, it's 25 plus 16 is 41. But in terms of play an instrument, you could see that just looking at this table here, the total number that play an instrument would be 41 students. Okay. So in terms of the next question here, how many students speak a foreign language, we could see that looking at the foreign language row, we can look over here and say there must be 46 students that speak a foreign language. So in terms of play an instrument, foreign language total, we look at the totals for that row or that column. Now letter C says, how many students play an instrument and speak a foreign language? And so we're talking about the intersection of these two things, which, Venn diagram wise represents this middle portion right here. But in terms of where this falls on this two-way table, we'd say how many students play an instrument and speak a foreign language. We say speak a foreign language, play an instrument. They intersect here, and so we'd have 16 total students that do this. So now looking at the next question, how many students do not play an instrument and do not speak a foreign language? So we'll look at the intersection of do not play an instrument, do not speak a foreign language. There are 9 of these students. And then letter E says how many students play an instrument and do not speak a foreign language. So play an instrument, that'd be this first column. Overlapping with our do not speak a foreign language, that'd be these 25 students right here. So you can see that looking at these frequencies is pretty easy to answer these questions. When we look at the second part of this, we're going to look at how we could determine probabilities doing or using these frequencies. So we'd say working with somebody here on your own, we say in exploration 1, this guy here, says one student is selected at random from the 80 students who took the survey. So we're just going to pull one person right out of the hat here. And we want to find the probability of these things occurring. So as we do this here, the first thing we always want to do is represent our probability symbolically. So we say plays an instrument, instrument. And just to be clear, we say plays, plays an instrument. That's a comma right there. But the probability they play an instrument, the first thing we want to recognize is that the sample space size, or the total overall number of students here, was 80. And so that sample space size, we could write this right here, sample space size is always going to be this total of the totals down here in this bottom right corner typically. So we'd say, well, how many people play an instrument? What we're going to do is we're going to say, well, how many people play an instrument? Looking over here, we say it's this 41 that we got right here. So we say 41 divided by 80. And of course, we'd want to pull out a calculator here and say 41 divided by 80. And we should get a percentage that's a little bit bigger than a half. We get about 51.25% chance, okay? In terms of the next question, we say, what's the likelihood that they speak foreign language? We would say still out of 80 here. But in terms of speaking a foreign language, we actually concern ourselves with this over here. We'd say speaking a foreign language, there are 46 total students that do this. So it should be greater than 51.25%. As a matter of fact, if we take 46 divided by 80 here, we get about 57.5%. So 57.5%. So rolling through these, you can see that these kind of mirror these situations over here on the left. What I want to look at though is, again with the table here, we say, how could I determine the probability that a student at random plays an instrument and speaks a foreign language? So we're going to say, plays instrument, and language. We'll assume that they do both of these things. So we'd say, out of 80 kids, how many people played an instrument and spoke a foreign language? We'd say, looking at this, we said, speak a foreign language and play an instrument was 16 out of 80 here. And of course, we should reduce this if at all possible. It didn't reduce up here. But for example, this would be something like 8/40, which would be the same thing as 1/5. And so without my calculator, I can tell you that's 20% chance right here. So these last two, let's go ahead and see what we get. Probability, instrument, bar, not an instrument, okay, and language, bar, or the complement to language, or anything but a language here. So we say not instrument and not language. We would say, well, how many people do not play an instrument and do not speak a foreign language? We'd had 9 of those people right there. So 9/80 here, I suppose would be just 9/80, and we'd say 9 divided by 80. So we get about 11.25%, or we get exactly 11.25%. And for this final question here, we say plays an instrument, got my M better on that one, and not a language. Okay, so the complement to language here. And so we would say that out of 80 here, how many people play an instrument but do not speak a language? We said that was 25 people right there. We say do not speak a language, play an instrument, 25. So 25 out of 80. Of course, we would reduce this. We say 5 out of, I believe it is 16. And if we divide this out, whoops, wrong calculator here, we say 5 divided by 16, just checking here. Would that be the same thing as 25 divided by 80? See, check my math. I did do it right, so we say 31.25%. So in the next video, we're going to define some vocabulary when it comes to making these two-way tables, but we're really going to focus on these two-way tables and how we could more clearly find probabilities in general. Cheers.